Today is Monday, September 5th, 2022. It is also day 414 of data science. And today I just wanted to really quickly go back to day 412, where I basically had nonlinear data that, well, wasn't linear, and I linearized it using the power model. And so just to kind of sum things up, this graph basically summarizes I had the original data, it wasn't linear, you can see like a slight curve, and then I linearized the data. So the purpose of this is so that I could get the least squares regression line. So I'll actually, let me see, I'll actually take this data over here. Maybe I'll just run it from here. So maybe I'll do an extension. So I'll take Seaborn and I'll do reg plot. And I'll put in df, let's say x, and then df y, which is the original data. So I'm just going to run things from the beginning. All right, so this is the least squares regression line for the original data. But if I just copy this and I put in the new data, which I think is called df linear, so I'm just copy this over here and paste that in there and just plot the regression line for the new data, I'll be able to see that it actually fits the data incredibly well. I mean, more like so much better than the first one. And so that's kind of the point of linearizing data so that you can have the least squares regression line, like the best line of fit, which is literally the line that has the least squares. So that kind of sums things up. And so now that I have my line linearized, or my data linearized, I can now get the actual equation of the line and then use that line to predict values. So to get the equation, I'm gonna import SciPy as SC, and then I'll do sc.stats.lin regress, and hopefully I spelled that right. And then all I have to do is just pass in the values of the new data set, and I'm able to get the slope, the intercept, and some other stuff which is irrelevant for now but very important. But slope and intercept are the what do you call it, the most important things. And this is the equation of the line at this point. So I know that let's see, for a normal regression line it is predicted y, so I'm just going to say y hat is equal to, I believe it was a plus bx, so a being the y-intercept and b being the slope. So essentially what I'm getting at is right now y hat is actually equal to -1 plus 2x. And I also have to know that because this is a power model, it's actually now log of y hat and then also log of x. And that is, where is that? Okay, log of x. Now, yeah, that's pretty much it. So this is the equation for the line that I have right now. And don't quote me on this, but I'm not even sure if I should add the log or not, because the linear line is y hat is equal to -1 plus 2. But because I took the log of y and the log of x, wouldn't I have to add that? So that's a question I have. Let me try to figure that out and try to think about that. Right, so I was just double checking with my math up here. The data frame, these are the values. So if I put in a 3, I should get a 5. And if I put in a 3 for this with a log, I don't get a 5. And so, yeah, my bad, but like, I don't do logs here. So let me delete the logs. Okay, and then this would be the final equation for that regression line, right? So that makes sense because it should be linear, right? And so then that line we can use to predict future values. And then from there, something that I might have to research is how do we kind of define, like, how do we return back to how it was? Like, I know mathematically how to do that, but then if I'm predicting values for a line that's like, because this is not the same data, it's transformed now. So wouldn't the predicted values also be transformed? Like, I don't know, how would you relate them to the previous values is my question. So that's a question for another day. But I'm gonna just really quickly use this equation to just kind of do some predictions. So, for example, this has no context, it's just x and y, but let's pretend like, I don't know, maybe x is your, no, that's, let me try to think. Yeah, it wouldn't make sense, but let's just pretend that x is like your reading score. Or let's say no, let's say your writing score. X is your writing score, like in a class, and then Y would be your reading score. So we're trying to look at the relationship between X and Y, your writing score and your reading score. So let's say I can put in a writing score and get a reading score back, like a predicted reading score back. So using this equation, I can do that. So I can just do, let's say, Y is equal to -1 plus 2x, well, 2, let's say 2 times x. And then I can set my x equal to, let's say, I don't know, 3, and then I can print out y, and y would end up being my predicted, like, what is it, reading score? So to put it in context, my writing score, let's say I want to know what my predicted reading score actually would be if I got like a 3 on a writing score. So then same thing, I would just kind of copy this over here and just change this to reading score. And what's my X writing score? Put that in there and just print out my reading score, right? Run that and it should equal, right? 5, same thing, just to put it in context. So that's what you can do essentially. Yeah, so that's it for today. I'm gonna go now. Bye.